Hello there, and welcome to the Sleepy Space Channel. Tonight, we travel out to Saturn and to the unsettling truth hidden beneath the most beautiful planet we know. At first glance, Saturn is all elegance, wrapped in its iconic rings. But the longer you look, the more you realize something here is not right. This is a world slowly tearing its own rings apart and devouring them. A world with a perfect six-sided storm at its pole, a shape that by every law of weather should not exist. A world whose magnetic field is so flawlessly ordered that our best physics says it should be impossible. This documentary follows all three of those mysteries, the ones our science still cannot fully explain. If you enjoy these gentle journeys, I invite you to like, subscribe, or share a thought below. It helps others find their way here too. One sleepy soul at a time. But for now, there is nothing you need to do but settle in. Let your shoulders soften. Let your breathing slow. Allow your eyes to grow heavy. Let's begin. Part 1. The Ringed World at the Edge of the Light. Saturn is the sixth planet from the Sun and the second of the great gas giants. It moves through the outer solar system at a distance of roughly 9.5 times the gap between the Earth and the Sun. At that range, sunlight arrives thin and pale and cold. The Sun, seen from Saturn, would be only a brilliant point, far too small to warm anything, no longer the wide golden disk that the inner planets know. For most of human history, Saturn was simply a slow point of light. It is the most distant planet that can be seen without a telescope, and it moves so gradually against the background stars that it takes almost 30 years to complete a single circuit of the sky. A person could be born under Saturn in one constellation and reach the end of a long life before the planet returned to the same place. It is a world that keeps a slower calendar than we do. Then the telescope arrived, and Saturn became something stranger. Early observers saw a small disk with something around it that they could not quite resolve. It looked, at first, like handles, or like a pair of companions, standing on either side of the planet. Only later did the true shape become clear. Saturn was wearing a ring, a flat and continuous band encircling the whole world, tilted toward us so that we could see its breadth. No other object in the sky looked anything like it. Saturn is the second largest planet in the solar system, smaller only than Jupiter. About 9.5 Earths could be set side by side across its face. More than 700 Earths could be packed into the space it fills. And yet, for all that size, Saturn is not a heavy world in the way its bulk suggests. It is made almost entirely of the two lightest elements there are, hydrogen and helium, the same materials that make up the Sun. The planet is enormous, but it is loosely built. This leads to one of the gentlest and most surprising facts about Saturn. It is the only planet in the solar system that is less dense than water. If there were an ocean somewhere large enough to hold it, Saturn would float. The image is almost absurd, a world that wide and that grand resting on the surface of a sea like a vast pale buoy. But the arithmetic is real. Saturn is mostly light gas, gently compressed, and it weighs less, for its size, than the water in any lake on Earth. Because it is a gas giant, Saturn has no surface. There is no ground anywhere on the planet, no shoreline, no rock to stand upon. A traveler descending into Saturn would simply pass through gas that grew slowly thicker and warmer and darker, until the gas behaved more like a liquid, and then like something stranger still, with no single moment at which atmosphere ended and planet began. Saturn is a world without a floor. It is layers, all the way down, fading one into the next. The planet turns quickly for something so large. A single day on Saturn, one full rotation, lasts only a little over 10.5 hours. The whole vast globe, wider than 9 Earths, completes a turn in less than half the time the Earth takes. This rapid spin matters because it shapes everything that happens in the atmosphere. It stretches the clouds into long parallel bands. It steers the winds. And, as we will see, it is part of why the storms at Saturn's poles behave so strangely. Saturn's axis is tilted, much as the Earth's is, by roughly 27 degrees. Because of that tilt, Saturn has seasons. But a Saturnian season is not measured in months. It is measured in years. Each one lasts for the better part of a decade, as first the northern hemisphere and then the southern leans toward the distant sun. The tilt also changes how we see the rings from Earth. Sometimes they are presented to us wide open, a broad, bright ellipse. Sometimes they are turned edge-on, and from our distance they nearly vanish because they are so astonishingly thin. Almost everything specific and surprising that we know about Saturn comes from a small number of robotic visits. 2 early spacecraft passed the planet within about a year of each other, flying by at speed and sending back the first detailed photographs of the rings and the clouds. They did not stay. They were on their way outward, toward the edge of the solar system, and they glimpsed Saturn only in passing. But what they glimpsed was enough to show that the planet held puzzles. Decades later, a single spacecraft was sent not to fly past Saturn but to stay. It settled into orbit and remained there for 13 years. It watched the planet through the slow turning of its seasons. It flew again and again past the moons. It dove, near the end of its mission, through the narrow gap between the planet and the innermost edge of the rings, a place nothing had ever traveled before. And then, when its fuel ran low, it was sent down into Saturn's atmosphere to end as part of the planet it had studied. The long, patient survey carried out by that orbiter is the source of nearly everything strange we are about to explore. There is even a sound associated with Saturn, though it is not a sound in the way we usually mean. Saturn gives off radio waves, natural emissions generated by the planet and its environment. When those radio signals are translated into something the human ear can register, they become an eerie, shifting wash of tones, rising and falling, almost like a voice. It is not noise carried through air. Saturn has no air that would carry sound to us. It is the planet's invisible radio glow made audible, a quiet signal drifting out from a world far away in the dark. So this is Saturn at a first glance. A pale, slow, enormous, lightly built world, far from the sun, wearing a ring that nothing else in the solar system can match. It is, by almost any measure, one of the most beautiful planets we know. But beauty is only the surface of it. The longer anyone looks at Saturn, the more they begin to notice that something here is not quite ordinary. There are 3 things about this planet that our science has studied for decades and still cannot fully explain. 3 quiet puzzles, each one stranger than the last. We will take them slowly, one at a time, and we will begin with the rings themselves, because the rings are not what they appear to be, and they are not going to last. It is worth lingering, before we go on what it means for a planet to have no surface, because it is a strange idea, and an unfamiliar one, and the night is long, and there is time to sit with it. Every world we know from our own lives has a flaw. The Earth has its ground. The Moon has its dust and rock. Mars has its red plains. Even the smaller worlds, the moons and the asteroids, have a surface a traveler could stand upon, however cold or barren it might be. We are creatures of solid ground, and we expect a planet to have a place where the falling stops. Saturn offers no such place. A traveler descending into Saturn would fall and keep falling through gas that thickened with every kilometer but never became a floor. The transition from atmosphere to interior is not a line. It is a long, gradual, deepening, gas giving way to dense fluid, giving way to stranger states, still, with no boundary ever crossed, no moment of arrival. There is no depth at which one could say, here, this is the surface of Saturn. The planet is a gradient. It is a slow change of state from the thin cold haze at the top down to the crushing dark at the center. And nowhere in all that descent is there a single hard edge. To understand Saturn at all, that idea has to be accepted early and held onto. It is a world made entirely of layers, fading one into the next. Consider, too, the planet's distance, because distance is part of what makes Saturn what it is. Saturn orbits the Sun far out in the cold, roughly 9.5 times farther from the Sun than the Earth is. Sunlight, spreading out from the Sun, grows fainter with distance, and by the time it reaches Saturn, it is roughly 1% as strong as the sunlight that falls on the Earth. A noon on Saturn would be a deep, soft twilight by our standards. The Sun, in Saturn's sky, would be a small and brilliant point, dazzling to look at, but far too small to warm the planet, no longer the broad golden disk that the inner worlds know. This is why Saturn's own internal warmth matters so much, and we will return to it later in this journey. A world this far from the Sun, receiving so little light, cannot rely on the Sun to drive its weather or to keep it from freezing entirely. Saturn must, in a real sense, keep itself warm. The planet carries its own heat, generated and stored deep within, and it is that inner warmth, far more than the distant Sun, that stirs the great winds and feeds the storms. Saturn is, in this respect, a planet that lives by its own fire, and the cold of its surroundings is genuine and deep. The upper atmosphere of Saturn, the part we can see, the part wrapped in pale haze, is one of the colder places among the planets, far colder than the bitterest winter the Earth has ever known. The pale gold serenity of Saturn's clouds is the serenity of a very cold place, a calm born partly of the deep chill of the outer solar system. To picture Saturn truly, one has to picture not warmth and brightness, but a vast, pale, frigid grandeur, a beautiful cold lit softly by a sun grown small with distance. There is one more thing to hold in mind about Saturn before we go further, and it concerns time. Saturn keeps a slower calendar than we do, and almost everything about the planet has to be understood against the long, unhurried rhythm of its year. 30 Earth years to 1 Saturnian year. A season that lasts the better part of a decade. A great planet-circling storm that erupts only about once each Saturnian year, which is to say, about once a human generation. A spacecraft watching the planet for 13 years sees less than half of 1 Saturnian year pass. To know Saturn through a full cycle of its seasons would take a human lifetime of patient watching. The planet does nothing quickly. It turns, it drifts, it changes, all at a pace far slower than a human life. And there is something fitting, something quietly restful, in spending a slow night in the company of so unhurried a world. Part 2. The rings that are falling away. The rings of Saturn are the first thing anyone notices about the planet, and they are the first of its mysteries. To understand what is strange about them, it helps to begin by setting aside the picture most of us carry. The rings are not a solid object. They are not a flat disk of metal or stone. They are not a shell, not a band, not a single connected thing of any kind. Seen from far away, they certainly look that way. They look like a smooth, polished sheet, wrapped neatly around the planet, gleaming in the pale sunlight. But that smoothness is an illusion of distance. The rings are made of countless separate pieces. Each piece is an individual object, ice or rock, traveling on its own orbit around Saturn. There is no sheet holding them together. There is only an immense crowd of particles, so many of them, and spread so evenly that from a distance they merge into the appearance of a single glowing band. If a traveler were to fly close to the rings, the illusion would dissolve completely. The solid disk would break apart into a vast, slow swarm of tumbling fragments, each one drifting along its own path, with dark, empty space between them. The particles themselves vary enormously in size. Some are as fine as dust, mere specks suspended in the swarm. Some are the size of grains of sand. Others are pebbles, or boulders, or blocks of ice as large as a house. A few are larger still. They are mostly water ice, frozen hard in the deep cold of the outer solar system, and that is why the rings shine so brightly. Ice is an excellent mirror for sunlight. A smaller share of the material is rocky or dusty, mixed in among the ice, but it is the ice that gives the rings their brilliance. The rings are vast. They reach across hundreds of thousands of kilometers, far wider than the planet they encircle. If you could somehow see them laid out at the scale of the Earth, they would stretch a significant fraction of the way to the Moon. They are one of the widest single structures anywhere in the solar system, and yet they are almost unimaginably thin. This is the detail that startles people most. Across most of their enormous width, the rings are only about 10 meters thick. In some regions, even less. 10 meters, the height of a few floors of a building. A structure that spans hundreds of thousands of kilometers in two directions, and just 10 meters in the third. There is nothing else quite like it. Compared to their breadth, the rings are far thinner in proportion than a sheet of paper. If you shrank the rings down until they were as wide as a football field, they would be thinner than the edge of a razor blade laid flat upon it. This is why the rings can almost disappear from our view. When Saturn's slow seasons turn the ring's edge on toward the Earth, we are looking at that 10-meter dimension across a distance of more than 1 billion kilometers. The rings simply thin out to a faint line, and then to nearly nothing. A structure wide enough to be seen across the solar system becomes, for a while, almost invisible, purely because it is so flat. Within that immense thin disk, every particle moves on its own. And the particles closer to Saturn travel faster than the particles farther out, in exactly the same way that the inner planets circle the Sun faster than the outer ones. This means the rings are not turning like a solid wheel. A wheel turns all in one piece. The rings do not. They are a slow, layered flow, an endless sliding of ring past ring, the inner material always drawing ahead of the outer. The whole structure is in gentle, ceaseless, differential motion, a quiet shearing that never stops. Now we come to the part that is genuinely surprising. The rings of Saturn are not permanent. They are disappearing. Saturn is slowly losing them, and it is losing them by its own action. The planet is, in a real and measurable sense, pulling its rings apart and drawing the material down into itself. The most famous feature of the most famous planet in the sky is a temporary one, and we are watching it during the long, slow process of its undoing. The mechanism behind this is sometimes called ring rain, and it is worth following carefully because it is a beautiful piece of physics. It begins with Saturn's magnetic field. Saturn is wrapped in one of the strongest planetary magnetic fields in the solar system, an invisible structure of magnetic force reaching far out around the planet and through the region where the rings orbit. The ice particles in the rings do not stay electrically neutral forever. Several things act on them. Sunlight strikes them. A steady, faint drizzle of microscopic dust from space bombards them. Radiation washes over them. Through these processes, little by little, the particles pick up a small electric charge. They become, in the language of physics, electrically charged grains, rather than neutral ones. And an electrically charged particle behaves differently from a neutral one. A neutral particle feels only gravity, and gravity alone will keep it in a stable, steady orbit, circling Saturn indefinitely. But a charged particle feels something more. It feels the magnetic field, and the magnetic field can take hold of it. Once a ring particle becomes charged, the planet's magnetism is able to grip it and to pull on it, and the particle's quiet, stable orbit is no longer quiet or stable. The magnetic field guides the charged particle inward. Instead of continuing on its long circular path, the particle is drawn down, steered along the invisible lines of magnetic force, pulled toward the planet. It does not fly off into space. It does not scatter outward. It falls inward towards Saturn. It is carried down into the upper atmosphere of the planet, and there it is lost, absorbed into the great body of gas below. And this is not something that happens once, or rarely, or in one place. It is happening everywhere around Saturn, all the time, every second. Across the whole span of the rings, charged particles are continuously being lifted out of their orbits and rained down into the planet. It is a steady, invisible inward fall of ring material, a constant drain. Saturn is quietly absorbing its own rings, drawing them into itself the way a slow tide draws sand down a beach. There is something almost tender, and certainly strange, in that picture. Saturn is not being robbed by anything from outside. No passing object is stealing its rings. The planet is taking them itself, gathering its own most beautiful feature back into its body, particle by particle, year by year. The rings are draining into Saturn like the sand in an hourglass slipping grain by grain into the lower chamber. How long do the rings have? Estimates differ, because the rate of the rain is difficult to measure precisely, and it changes from place to place. But the broad picture that astronomers draw is consistent. At the present rate of loss, the rings could be substantially gone in a span of time that is, by the standards of the solar system, quite short. Not tomorrow. Not in any human timescale, but far sooner than the age of the planet itself. Saturn has existed for billions of years. Its rings, by many estimates, may have only tens or hundreds of millions of years remaining. In the long life of the planet, that is the closing chapter of a book, not the whole story. And here the mystery deepens, because the same reasoning runs in the other direction as well. If the rings are vanishing this quickly, then they probably also appeared comparatively recently. A structure that drains away in a few 100 million years cannot have been sitting there, untouched, for the 4.5 billion years of Saturn's existence. It would already be long gone. The most natural conclusion is that the rings are far younger than the planet they encircle. For most of Saturn's history, it seems, the planet had no rings at all, or had different ones that have since disappeared. There is supporting evidence for this youth. The ice in the rings is strikingly clean and bright. Out in the solar system, ice does not stay clean. It is constantly dusted by the dark microscopic debris that drifts everywhere through space. An ancient ring system, billions of years old, would by now be deeply darkened, its ice dimmed and grimed by eons of infalling dust. Saturn's rings are not dark. They are brilliant. That brightness is hard to reconcile with great age, and much easier to explain if the rings are young, if they have simply not had enough time yet to gather their coating of grime. Put those two facts together, and a quietly remarkable picture emerges. The rings of Saturn were not always there, and they will not always be there. They appeared, by cosmic standards, not so very long ago. They are draining away even now. And we, looking up at Saturn and seeing its rings, happen to be alive during the relatively brief stretch of time in which they exist. The image of Saturn that every child draws, the ringed planet that everyone on Earth recognizes instantly, is a snapshot of a passing moment. There were long ages of Saturn before the rings, and there will be long ages after them. This is simply the chapter we were born into, and we were fortunate in our timing. If the rings are young, then something must have created them, comparatively recently, out of the material of the outer solar system. The leading ideas all share a common thread. They involve the breakup of an icy body. Perhaps one of Saturn's own moons drifted too close to the planet over time. Perhaps a large comet, a wanderer from the outer dark, swung in towards Saturn and was captured by its gravity. In either case, an icy world that came too near to Saturn would face the planet's tides. The same gravitational forces that raise the tides in Earth's oceans become close to a giant planet, powerful enough to pull a small body apart entirely. An icy moon or comet, drawn inside a certain distance of Saturn, would be stretched and broken, shattered into countless fragments. Those fragments, continuing to orbit, would spread out over time into a thin, broad disk. They would become a ring. The rings, in this picture, are the remains of something. They are the gentle, glittering wreckage of an icy world that came too close to Saturn and was undone. There is a quiet poetry in that, and no horror in it at all. The breaking happened, if it happened, in the deep past. What is left is only beauty, a slow, bright disk of ice, turning patiently around the planet. The rings are not a single uniform band. Looked at closely, they are divided into several broad sections, separated by gaps, regions that have been swept comparatively clear of particles. The most famous of these gaps is a wide, dark lane that can be seen even through a small telescope from the surface of the Earth, a clean, dark stripe dividing the bright rings into an inner and an outer portion. These gaps are not empty by accident, and they are not flaws in the rings. They are shaped, deliberately and continuously, by gravity. The sculptors are moons. Saturn has small moons that orbit within the rings, or close beside them, and the gravity of these little moons constantly tugs at the ring particles around them. A small moon can herd the ice, nudging particles away from certain regions and gathering them into others. It can clear a lane and keep it clear. It can sharpen the edge of a ring into a crisp, clean boundary. Moons that do this are sometimes called shepherd moons, and the name fits. They move among the ring particles like quiet herders among a flock, keeping the rings tidy, holding the gaps open, pressing the edges into shape. Some moons keep a gap swept clear simply by sharing its orbit, scattering away any particle that drifts into their path. And within the rings themselves, the long survey of the planet found delicate detail everywhere. There are waves rippling through the ring material, spiral patterns spreading outward. There are places where the ring is briefly lifted into small vertical structures, tiny ridges and walls of ice rising up out of the flat plain, casting shadows, like the wake spreading behind a boat. The rings, which look so smooth and still from far away, are alive with quiet motion when you come close. Beyond the bright main rings, far out from the planet, there are fainter rings as well. These outer rings are vast and tenuous, made of fine dust, so thin and so faint that they are nearly invisible. One of them is enormous, a huge ghostly halo of dust reaching far out around Saturn, fed by material knocked off a distant moon. It is so faint that it went unnoticed for a long time, hiding in plain sight, a ring almost too gentle to see. So the rings of Saturn, the planet's most familiar feature, turn out to be the strangest kind of structure. Not a solid disk, but a swarm of countless separate worlds in miniature. Wider than the gap to the moon, and thinner than a sheet of paper. Brilliant with clean ice, and probably young because of it. Quietly draining, even now, into the planet that holds them. Shepherded and shaped by small moons that herd the ice into lanes and walls. They are beautiful, and they are temporary, and they are already, slowly, on their way to becoming something else. That is the first of Saturn's mysteries. The second one waits at the planet's northern pole, and it is a shape that, by every ordinary expectation, simply should not be there. It is worth dwelling a little longer on the sheer number of particles in the rings, because the number is part of the wonder, and numbers this large are restful to contemplate slowly. The rings are not made of thousands of pieces, or millions, or even billions. They are made of a quantity of separate objects, so vast that the mind cannot truly hold it. Every block of ice, every boulder, every pebble, every grain, every speck of dust is its own small world, on its own small orbit, obeying the same laws of motion that govern the planets themselves. The rings are, in effect, a swarm of uncountable tiny moons, each one circling Saturn in perfect, patient obedience to gravity. And the swarm is not still. Each particle moves at the speed its distance from Saturn demands, the inner ones swift, the outer ones slow, and so the whole great disk is forever sliding against itself, ring against ring, faster material always drawing ahead of slower. The particles jostle. They brush against one another, gently, constantly. They collide, softly, at low speeds, and rebound and drift on. The rings are not a frozen sculpture. They are a slow, living flow, a vast, quiet machine of ice in perpetual, gentle motion, and they have been turning that way for as long as they have existed. There is a question that naturally arises when one pictures the rings closely, and it is a question worth answering plainly. If the rings are made of countless separate particles, all colliding and jostling, why do they not simply spread out, or clump together, or scatter into chaos? Why do they remain a thin, orderly, beautifully flat disk? The answer is gravity, working patiently over enormous spans of time. The gentle collisions between particles, repeated endlessly, tend to average out the motion. A particle on a tilted or stretched orbit, colliding again and again with its neighbors, is slowly nudged toward the common plane and the common rhythm. Over long ages, this ceaseless, gentle bumping flattens the swarm into the thin sheet we see. The flatness of the rings is not an accident. It is the patient work of countless soft collisions, smoothing the disk over time, the way a still pond settles flat after a stone has been dropped into it. Now return to the matter of the ring rain, because it rewards a closer and slower look. We described how charged particles are pulled out of the rings and rained down into Saturn. But it is worth picturing the scene more fully, because it is a quietly extraordinary thing to imagine. All around Saturn, in a region we cannot see with the eye, there is a constant, gentle fall. From the inner edge of the rings, and from places across their span, fine, charged material is being lifted away and guided down along the curving lines of the magnetic field, streaming inward, settling into the upper atmosphere of the planet. If a traveler could see the magnetic field and could see the charged ring material moving along it, they would see Saturn wrapped in a soft, endless, inward-falling rain, a quiet downpour of its own rings, falling forever into the planet. And this rain is not without effect on Saturn itself. The material that falls in does not simply vanish. It arrives in the upper atmosphere of the planet, and it changes the chemistry there, leaving its mark in the high clouds where it lands. By studying those marks, by reading the chemistry of Saturn's upper atmosphere, astronomers can actually trace where the ring rain is falling and how heavy it is. The planet, in effect, keeps a faint record of the rain in its own sky, and that record is part of how the rate of the ring's disappearance has been estimated. The rings write their own slow ending into the atmosphere of the world that is absorbing them. It is natural, hearing all this, to feel a small pang at the thought of the rings being lost. They are so beautiful, and the idea of them draining away can seem like a kind of diminishment. But it is worth holding the thought more gently than that. The rings are not being destroyed in any violent sense. They are being returned. The ice that made an icy moon or a wandering comet long ago was broken into a ring, and now, slowly, that ice is being gathered home into Saturn, becoming part of the planet's atmosphere, part of its weather, part of its body. Nothing is lost from the universe. The material simply moves on, from world to world again, in a slow cycle that runs on a timescale far longer than any human concern. There is no tragedy in it. There is only change, unfolding at the patient pace at which the solar system has always changed. And the timing of our own existence, set against the lifespan of the rings, is worth sitting with as a quiet wonder rather than a loss. Human beings have existed for a very short time, by the measure of the solar system. Civilizations with telescopes have existed for an eye blink. And yet that eye blink happens to fall within the relatively brief chapter in which Saturn wears its rings. We did not have to be born in a ringless age. We were not. We arrived in time to see the ringed planet, to draw it, to photograph it, to send a spacecraft diving through the gap between the rings and the world. There is a kind of quiet good fortune in that, the same gentle good fortune as in stepping outside on the one clear night, and it is a more peaceful thing to feel than any sense of loss. The structure within the rings deserves one more slow pass as well, because it is more intricate and more delicate than the simple word rings suggests. The bright main rings are not a smooth gradient of ice. They are divided, on close inspection, into a great many narrow ringlets, fine bands and bright lines and subtle gaps, layer upon layer of detail, like the grooves of an old record seen from above. Some of this fine structure is shaped by the small shepherd moons. Some of it is shaped by the gravity of the larger, more distant moons, whose steady tugging, repeated on every orbit, can pile ring particles into waves or carve them into gaps at particular distances from the planet, the distances where the rhythms line up. The rings are, in this sense, a record of the gravity of everything around them. Every moon of Saturn has left its quiet signature somewhere in the ice. To read the rings closely is to read a map of all the gentle forces at work in Saturn's system. And the vertical structures, the small walls and ridges of ice that briefly rise out of the flat plane of the rings, are perhaps the most delicate detail of all. In most places, the rings are flat to within a few meters. But near certain ring edges and around certain small moons, the ice can be lifted into thin vertical walls, rising for a kilometer or more above the ring plane, casting long shadows across the ice when the sunlight strikes them at a low angle. These shadows were how the walls were first noticed. dark lines stretching across the bright rings, betraying structures too thin to see directly. They are temporary, raised by the passing gravity of a small moon, and then settling again. They are the closest thing the rings have to mountains, brief soft mountains of ice, rising and falling as the moons go by. Part 3. The hexagon at the northern pole. At the northern pole of Saturn there is a shape, and the first time anyone sees it, the natural reaction is to assume it is a mistake. It does not look like weather. It does not look like anything a planet should produce on its own. Centered almost exactly on the pole, drawn across the cloud tops of a giant world, there is a hexagon, a six-sided figure. 6 straight edges, meeting at 6 clean corners, arranged with a regularity that looks deliberate, almost designed. It is worth pausing on how unexpected this is. Saturn is a sphere of gas. It has no edges anywhere. It has no corners, no straight lines, no flat surfaces, nothing rigid or angular about it at all. It is the smoothest kind of object there is, a great round ball of hydrogen and helium turning in space. The weather of such a world should reflect that smoothness. On every gas giant we know, the storms and the cloud patterns organize themselves into rounded forms. They make bands and stripes. They make ovals and spirals. They make swirling circular vortices. They curve. That is what fluids in motion do. They do not, as a rule, make straight lines, and they certainly do not assemble themselves into neat geometric polygons. And yet, around Saturn's northern pole, there are 6 straight edges. A clean hexagon, the kind of figure a student might draw with a ruler, traced out in the clouds of a planet that has no rulers and no straight edges anywhere else upon it. What the hexagon actually is, in physical terms, is a storm. More precisely, it is the path of a powerful jet stream. High in Saturn's atmosphere, near the northern pole, a fast river of wind flows in a great loop around the planet's axis. On any other world, that looping wind would simply trace a circle. Here, for reasons we will come to, it does not. It traces a 6-sided path instead. The hexagon we see is the track laid down by that circling wind, the visible mark of a jet stream that has, somehow, settled into the shape of a polygon. The scale of it is difficult to take in. The hexagon measures roughly 30,000 kilometers across. The whole of the Earth, from one side to the other, is a little under 13,000 kilometers. This means that more than 2 Earths, set side by side, would fit within the span of Saturn's hexagon. It is not a small curiosity tucked away at the pole. It is a feature wider than 2 of our planets, a geometric storm large enough to swallow worlds. And it rotates. The entire 6-sided pattern turns, slowly and steadily, around the pole. It does not wobble. It does not tumble. It does not fall apart and reassemble. It turns with a smooth, almost mechanical regularity, holding its shape perfectly as it goes, like a great slow gear set into the top of the planet. The hexagon was first glimpsed when the early spacecraft flew past Saturn and sent home their photographs. In those images, the 6-sided pattern was already plainly visible, ringing the northern pole. The initial response, understandably, was caution. A perfect geometric shape on a gas giant looked far more like an error in the data than a real feature of a planet. It was natural to wonder whether something had gone wrong with the images. But the hexagon was real. Decades passed. A new spacecraft, the long-lived orbiter, arrived at Saturn and settled in to watch. It observed the northern pole not for a few hours of a flyby, but for years, across a long span of the planet's seasons. And the hexagon was still there. The same six-sided shape. The same enormous size. The same position, centered on the pole. Across all the years between the first glimpse and the long survey, the hexagon had not dispersed, had not drifted, had not changed its form. It had simply remained. This endurance is the part of the mystery that deserves the most attention, because it runs against everything we understand about storms. A storm, by its nature, is a temporary thing. On Earth, storms form, build, and fade within days, or at most weeks. A hurricane is a structure of a week or two, and then it is gone. Even the largest, most famous storm in the solar system, the Great Red Spot on Jupiter, is not truly permanent. It has lasted a very long time, but it changes. It shifts. In recent times, it has been observed to shrink. Storms are events. They have beginnings and endings. Saturn's hexagon does not behave like an event. It behaves like a permanent feature of the planet. It has held its precise geometric shape, unbroken and unchanged, for at least the entire span of decades over which human instruments have been able to watch it. And almost certainly it held that shape for a very long time before anyone was looking, through all the centuries and the ages when no eye and no instrument was turned towards Saturn's pole. We simply began watching late. The hexagon was already there, already turning, already old. It is a storm that behaves like a monument, a piece of weather that has the permanence of architecture. When the orbiter studied the hexagon closely, it found that the shape was stranger still. The first natural assumption had been that the hexagon was flat, a pattern painted onto the cloud tops, a two-dimensional figure lying on the visible surface of the planet, like a design drawn on the skin of a balloon. That assumption turned out to be wrong. The hexagon is not flat. It is a tower. The six-sided structure does not merely sit on the cloud tops. It reaches downward, plunging hundreds of kilometers deep into Saturn's atmosphere. It is a vast vertical column of moving gas, hexagonal in cross-section, rooted far below the level of the clouds we can see. The hexagon at the surface is only the top of a far larger structure, a towering geometric shaft of wind standing in the body of the planet. And there was one more detail, stranger than all the rest. When the orbiter examined a separate, higher layer of Saturn's atmosphere, well above the visible hexagon, it found another hexagon. A second six-sided pattern, sitting in the air above the first, aligned with it, matching its orientation. It was as though the structure had a second story. The hexagon was not a shape at all, in the simple sense. It was a multi-level architecture, a geometric building made of wind, standing in the atmosphere of a giant planet, billions of kilometers from Earth. How does something like this form? Here we have to be careful and honest, because part of the answer is known, and part of it is not, and it matters to keep the two apart. The part that is understood is the shape itself. The bare fact that a hexagon can appear in a spinning fluid is not, by itself, mysterious. It can be reproduced in a laboratory. If you take a circular container of fluid and set it spinning, and you arrange for an inner region of that fluid to rotate at a different speed than the outer region, then the boundary between the two does not always stay a smooth circle. It can buckle. It can fold itself into a pattern of straight segments. Depending on the exact conditions, the speeds, the sizes, the depth of the fluid, that boundary can settle into a triangle, or a square, or a pentagon, or a hexagon. The mathematics of this is reasonably well understood. A jet stream flowing past slower moving fluid on either side can develop ripples and under the right conditions, those ripples lock into a stable wave with a fixed number of corners. A hexagon is simply one of the patterns that nature allows. Saturn helps the process along in one important way. It has no continents. The Earth's weather is so chaotic and so irregular, in large part because our planet has land. Mountains and coastlines and continents constantly interrupt the wind, slowing it here, deflecting it there, breaking up any smooth flow before it can organize itself. Saturn has none of that. It has no land, no mountains, no solid surface of any kind for the wind to catch on. A jet stream on Saturn can run clean and uninterrupted all the way around the planet without ever striking an obstacle. And a clean, uninterrupted flow is exactly the kind of flow that can settle into a stable, regular pattern and hold it. So that is the part we can explain. A spinning planet, a fast polar jet stream, no continents to disturb it, and the known physics of fluids allows a hexagon to form. If the question were only, why is there a hexagon at all, we would have a reasonable answer. But that is not the whole question, and the rest of it is not answered. The laboratory experiment explains why a hexagon can appear. It does not explain why this particular hexagon has been so extraordinarily stable, so enduring, holding its precise shape for decade upon decade without ever dissipating, when storms are, by their very nature, things that come and go. The laboratory shows a pattern forming. It does not show a pattern lasting through a span of time longer than human civilization has had telescopes. The depth of the structure is also not fully accounted for. The fact that the hexagon is not a flat pattern, but a deep tower, reaching hundreds of kilometers down into the planet, is harder to reproduce and harder to explain than the surface shape alone. What sustains it, most likely, is the heat of the planet itself. Saturn, as we will see, generates its own internal warmth, and that warmth wells up steadily from deep inside, driving the atmosphere from below. The hexagon, by this reasoning, is fed and maintained by the planet's inner heat, a quiet engine far below that keeps the great geometric storm turning. This is plausible. But plausible is not the same as proven, and the full account of why the hexagon is so deep, so stable, and so enduring does not yet exist. And there is one more puzzle, perhaps the most stubborn of all. Saturn has two poles. Only one of them has a hexagon. The northern pole holds the six-sided figure. The southern pole does not. At the southern pole, there is a storm, a large and powerful one. But it is an ordinary polar vortex. It is roughly circular. It is a great swirling cyclone, impressive in its scale and its strength, but it has no straight edges, no corners, no geometry of any kind. It is the kind of rounded, curving storm that one would expect to find at the pole of a giant planet. It is the southern pole behaving normally. This is the detail that resists explanation most firmly, because the two poles of Saturn are not fundamentally different places. It is the same planet at both ends. The same atmosphere, the same hydrogen and helium, the same internal heat rising from the same interior, the same rate of rotation, the same basic physics. By every measure we can apply, the conditions at the northern pole and the southern pole are very nearly the same. And yet one pole has assembled a perfect, enduring, six-sided geometric storm, and the other pole, under what appear to be matching conditions, has only an ordinary circular swirl. We do not know why. We can describe the difference precisely. We cannot yet explain it. There is a final, gentler strangeness to the hexagon, and it is a beautiful one. Over the years that the orbiter watched the northern pole, the hexagon changed color. Early in the long observation, the region enclosed by the six sides appeared bluish. a cool tone across the polar clouds. Later in the same mission, years on, that same region had shifted to a warm golden hue. The shape had not changed. The size had not changed. The position had not changed. Only the color was different, the whole interior of the hexagon slowly turning from blue to gold. The most likely explanation lies in Saturn's long seasons. The northern pole, over the course of the mission, was emerging from a long stretch of winter darkness and turning gradually into the light. As sunlight returned to the pole after years of shadow, it altered the haze and the chemistry of the upper atmosphere, and the color of the polar clouds shifted with it. That is probably the right explanation. It fits what we know. But, as with so much about the hexagon, it is offered as the best account available, rather than as a settled certainty. There is a great deal about this shape that we are still, patiently, working to understand. A giant geometric storm, wider than 2 Earths. A tower of wind reaching deep into the planet, with a second hexagon stacked above it. Stable for longer than we have been able to watch. Present at one pole and absent at the other, for no reason we can name. And slowly, across a season longer than a human decade, turning from blue to gold. That is the second of Saturn's mysteries. The third one cannot be photographed at all, because it is not a shape and not a storm. It is the planet's magnetic field, and its strangeness is the strangest of the 3, because the problem with Saturn's magnetic field is that it is too perfect. It helps, in understanding the hexagon, to think carefully about what a jet stream is, because the hexagon is, at bottom, a jet stream, and jet streams are not as exotic as they might sound. The Earth has jet streams of its own. They are fast, narrow rivers of wind, high in the atmosphere, flowing in great loops around the planet. They are why a flight in one direction can be faster than the same flight in the other. They are an ordinary feature of any large, rotating atmosphere. A spinning world with an atmosphere will tend to organize some of its winds into these fast, circling rivers. Saturn has jet streams as well, and Saturn's are far stronger and far more sharply defined than the Earth's, because Saturn spins quickly, has no continents to disrupt the flow, and is driven steadily by its own internal heat. The pale bands that stripe Saturn are, in large part, the visible signatures of these jet streams, fast winds flowing in alternating directions, banding the planet. The polar jet stream that traces the hexagon is one of these rivers of wind looping around the northern pole. The only unusual thing about it, and it is a very unusual thing, is that its loop is not a circle. Why a jet stream's loop should buckle into straight segments is the heart of the explained part of the puzzle, and it is worth following the idea slowly. Picture a fast river of wind flowing in a circle, with slower moving air on either side of it, inside and out. The boundary between the fast river and the slower air is not necessarily stable. A small ripple can develop along it, a gentle wave, a place where the boundary bulges slightly. And under the right conditions, that ripple does not simply fade away. It grows. It feeds on the difference in speed between the fast wind and the slow. And it settles into a steady, repeating pattern, a wave that runs all the way around the loop and joins up with itself. Because the wave must join up with itself, going all the way around, only certain patterns are allowed. A wave with exactly 6 bends around the loop will close neatly. So will a wave with 5, or 4, or some other whole number of bends. The exact number that nature selects depends on the details, the speed of the jet, the difference between the fast wind and the slow air, the size of the loop, the depth of the atmosphere. For Saturn's northern polar jet, the conditions happen to select 6. 6 bends, closing into a standing wave, and the path of the jet, tracing those 6 bends, draws a hexagon. That is the explained part, and it is a real and satisfying piece of physics. A hexagon is simply one of the shapes that a circling jet stream is allowed to settle into, and Saturn's happens to have settled into that one. But notice how much that explanation does not cover, and it is worth being honest and patient about the gap. The standing wave idea explains why the shape has corners, and even why it might have 6 of them. It does not explain why this particular wave on this particular planet has been so astonishingly steady. Standing waves in atmospheres are usually delicate things. They form, and they shift, and they break down, and they reform differently. They are not, as a rule, permanent. Saturn's hexagonal wave appears to be effectively permanent, holding the same 6 corners in very nearly the same places for decade after decade. Something is stabilizing it far more firmly than the simple standing wave picture would lead us to expect. And what that something is, in full, we cannot yet say. Nor does the standing wave idea explain the depth. A standing wave in the high winds might be expected to be a shallow thing, a pattern in the upper atmosphere. The hexagon is not shallow. It is a tower, reaching hundreds of kilometers down into the planet, with the geometry preserved all the way down, and with a second hexagon stacked in a higher layer above. A shallow ripple does not naturally explain a deep, multi-level, geometrically coherent column of wind. The hexagon is rooted in the planet in a way that the simple explanation does not reach. And the standing wave idea does not explain, at all, why only the northern pole has one. This is the part that should be sat with longest, because it is the part that most clearly marks the edge of what is understood. If a 6-cornered standing wave is simply a thing that a polar jet stream can do, then both poles of Saturn have polar jet streams, and both poles spin, and both poles are fed by the same internal heat. By the logic of the explanation, both poles ought to be equally capable of forming a hexagon. And yet the southern pole has not formed one. The southern pole carries an ordinary round vortex, a great circular cyclone with no geometry at all. The same planet has run the same process at both ends and produced a perfect hexagon at one and a plane circle at the other. Some small difference between the 2 poles, some difference we have not yet identified, has tipped the northern jet into its standing wave and left the southern jet circular. We can see the result with perfect clarity. We cannot yet name the cause. There is a temptation, faced with a shape this regular, to feel that it must mean something, that a hexagon is too orderly to be natural, that geometry implies intention. It is worth setting that temptation gently aside. Nature makes hexagons in many places, and always for ordinary reasons. The cells of a honeycomb are hexagons, because hexagons pack together without waste. The columns of certain cooled lava flows are hexagonal, because hexagons are how a shrinking, cracking sheet relieves its stress most evenly. Hexagons appear in foams, in cracked mud, in the patterns of certain crystals. 6-sided figures are not a sign of design. They are, very often, simply the most efficient or most stable answer to a physical question, and nature finds them again and again in entirely unrelated settings, with no intention behind any of it. Saturn's hexagon belongs to that same honest company. It is a natural shape, formed by natural forces, in a fluid obeying ordinary physics. It is strange not because it is unnatural, but because its endurance and its depth and its one-sidedness are not yet fully explained, and that is a very different and much gentler kind of strangeness. The color change of the hexagon deserves one more quiet look as well. because it ties the great geometric storm back to the slow turning of Saturn's year, and there is something soothing in that connection. When the orbiter first watched the northern pole closely, the pole was emerging from a long polar winter. For years, it had been turned away from the sun, held in shadow, and in that long darkness, the upper atmosphere within the hexagon had taken on a bluish cast. Then, across the years of the mission, the slow orbit of Saturn carried the northern pole gradually back into sunlight. The returning light went to work on the haze high above the pole, changing its chemistry, thickening it, and the color within the hexagon warmed from blue toward gold. The shape did not care. The geometry held perfectly steady through the whole transition. Only the color drifted, blue to gold, across a span of years, as one slow Saturnian season gave way to the next. The hexagon, in that sense, is a kind of clock. It keeps its shape and changes its color, marking the passage of a year so long that no human being could watch a single full turn of it, from start to finish. Part 4. The magnetic field that is too perfect. The third of Saturn's deep puzzles is the quietest of them all. It does not announce itself. It cannot be seen in any photograph. It has no striking shape, no dramatic motion, nothing that draws the eye. It is the planet's magnetic field. And the strange thing about Saturn's magnetic field is not that it is violent, or chaotic, or threatening. The strange thing is the opposite. Saturn's magnetic field is too neat. It is too orderly. It is so close to perfectly aligned that, by our current understanding of how planets generate magnetism, it should be very difficult for such a thing to exist at all. To see why that is strange, it helps first to understand how a planet makes a magnetic field in the first place. A magnetic field does not simply come with a planet, fixed in place like a property of the rock. It has to be generated continuously, and it has to be generated by motion. Deep inside a planet, there must be a layer of fluid that can conduct electricity. And that fluid must be in motion. It is stirred by heat rising from the planet's core, and it is shaped and steered by the planet's rotation, so that the conducting fluid is forever churning, swirling, circulating in great, slow currents. When an electrically conducting fluid moves like that, it generates a magnetic field, and it sustains that field for as long as the motion continues. This process, the generation of a planetary magnetic field by the motion of conducting fluid deep inside, is called a dynamo. The Earth has a dynamo. It runs in the liquid metal of our planet's outer core, and it produces the magnetic field that surrounds us, the field that guides, compasses, and shelters the planet from the solar wind. Jupiter has a dynamo. Saturn has one. Most of the large planets do. Now here is the key point, the point on which the whole mystery turns. The motion that drives a dynamo is turbulent. It is not smooth. It is not orderly. It is messy, chaotic, swirling, irregular flow. Heat, rising through a deep fluid, does not rise in tidy, even sheets. It rises in plumes and eddies and churning, disordered currents. The interior of a planet that is generating a magnetic field is a place of genuine chaos, a seething, restless, turbulent sea. And because the source of the field is messy, the field itself is usually a little messy too. In particular, a planetary magnetic field is normally tilted. The magnetic poles, the points where the field is strongest and most vertical, do not line up exactly with the geographic poles, the points where the planet's spin axis emerges. There is an angle between them. The magnetic axis leans away from the rotation axis. This tilt is the ordinary, expected condition. It is what the physics predicts, because a field born from chaotic flow naturally carries some of that chaos in its shape. We can see this tilt clearly across the planets. The Earth's magnetic field is tilted by roughly 11 degrees relative to its spin axis. That is why a compass needle does not point quite to the true geographic North Pole, and why the magnetic poles slowly wander over the years. 11 degrees of lean built into our own planet's field. Jupiter's magnetic field is tilted as well by about 10 degrees, a similar amount. And the magnetic fields of the more distant ice giants are tilted far more dramatically still, leaning at large angles and, in their case, offset well away from the center of the planet besides. A measurable tilt is simply the normal result of a turbulent dynamo. It is not a flaw. It is the signature of the chaos that produced the field. Every magnetic planet we can examine shows this tilt. Every one, that is, except Saturn. Saturn breaks the pattern, and it breaks it in a way that is genuinely difficult to account for. Saturn's magnetic field is aligned with its spin axis to an extraordinary degree. The tilt between Saturn's magnetic axis and its rotation axis is not 11 degrees, as on Earth. It is not 10 degrees, as on Jupiter. It is less than 1/10 of a single degree. As far as anyone has been able to measure, with all the precision the long orbital survey could bring to bear, Saturn's magnetic field and Saturn's spin point in the very same direction. The field stands almost perfectly straight along the axis of the planet's rotation. At first hearing, this can sound like the least mysterious thing imaginable. A neatly aligned field. A tidy planet. Where is the puzzle in something being orderly? But the tidiness is exactly the puzzle. Step back and consider what it means. A magnetic field produced by turbulent, chaotic, churning fluid ought to carry the marks of that turbulence. It ought to be at least a little crooked, a little off, a little leaning the way every other planet's field is. The chaos in the interior should leave its fingerprint on the field outside. Saturn's field carries no such fingerprint. Out of an interior that must be seething and disordered, the same kind of turbulent dynamo that every other magnetic planet runs, there emerges a magnetic field of almost flawless symmetry. No detectable lean. No measurable wobble. A field as straight and as aligned as if it had been set deliberately. And according to the standard understanding of how dynamos work, that should be very hard to achieve. The chaos is supposed to show. It is worth being precise about just how unusual this is, because the difficulty is sharper than simply not yet having an explanation. There is a long-standing result in the study of planetary dynamos, a piece of reasoning that has stood for many years, which states that a perfectly symmetric, perfectly axial magnetic field cannot be generated and sustained by a dynamo at all. The reasoning runs that a dynamo needs a certain degree of asymmetry in order to keep working. A perfectly symmetric flow, by this argument, cannot maintain a field. Some crookedness is not just expected. It is, in a sense, required. And Saturn's field sits very close to exactly the configuration that this reasoning says should not be maintainable. Less than 1/10 of a degree of tilt is so near to perfect alignment that Saturn appears to be doing something the basic theory of dynamos says a planet should not be able to do. So Saturn is not merely unexplained. It is, in a mild but real way, in tension with the rules as we currently understand them. Something inside that planet is hiding the asymmetry that ought to be there. Something is smoothing the field, combing it straight, erasing the lean before the field ever reaches the outside, and we do not have a confirmed account of what that something is. There is a candidate explanation, and it is a reasonable one. It is the leading idea, and it goes like this. Suppose that somewhere above the deep region where the dynamo runs, somewhere between the chaotic dynamo and the visible outside of the planet, there is a stable layer. A calm, smoothly rotating shell of fluid, quiet and even in its motion, not turbulent like the dynamo below it. And suppose the magnetic field, generated in the chaos beneath, has to pass up through this calm layer on its way out of the planet. If such a layer exists, it would act like a filter. As the messy, tilted field rises through the calm, smoothly turning shell, the steady rotation of that shell would blur the field, average it out, smear away its irregularities. The leaning and the wobbling would be smoothed in passage. And what finally emerged from the top of the planet would be far more symmetric, far more perfectly aligned than the field that was actually generated deep below. The chaos would still be down there. It would simply be hidden, screened from view by a calm layer that combs the field straight before we ever see it. This is an elegant idea, and it has the great virtue that it does not break the dynamo reasoning. The chaotic, asymmetric dynamo is still running, deep inside, exactly as the theory requires. It is only that its untidy field is being smoothed on the way out. Saturn would then be presenting a calm and ordered face to the universe, while concealing a turbulent interior behind a quiet, filtering shell. But the idea, for all its elegance, has not been confirmed. The existence of such a smoothing layer, its exact depth, its precise behavior, none of this has been directly demonstrated. The interior of Saturn is utterly beyond our reach. We cannot drill into a gas giant. We can only study the field from outside and model what might lie beneath, and reason carefully about what would be consistent with what we measure. The smoothing layer remains an idea that fits the facts, rather than a fact that has been shown to be true. And so we are left with the quiet, genuine strangeness at the center of this third mystery. Saturn shows the universe a face of perfect order. A magnetic field with no detectable flaw, no lean, no wobble, standing straight along the axis of the turning planet. But the interior that must lie behind that face cannot be orderly at all. The physics allows no calm dynamo. The inside of Saturn must be turbulent, chaotic, seething. The planet holds disorder within and presents perfect stillness without. There is nothing frightening in that. But there is something deeply uncanny about it, and uncanny is the right word. It is the strangeness of a perfectly still surface laid over a turbulent depth. It is the strangeness of a planet that has, somehow, learned to keep its chaos entirely to itself, and to show the rest of the universe only a smooth, calm, aligned, untroubled face. Of Saturn's three mysteries, this is the one that hides in plain sight, and it may be the one that runs the deepest. It is worth slowing down and considering, in a little more detail, what a magnetic field actually is, because the word is familiar, but the thing itself is easy to picture, only vaguely. A magnetic field is a region of influence, an invisible structure of force, reaching out around a magnetic object and shaping how other magnetic things, and electrically charged things, move within it. The Earth's magnetic field is the reason a compass needle swings to point north. It is the reason charged particles from the sun are steered toward the poles, where they light the sky with auroras. It is a vast, invisible architecture, generated by the planet, surrounding the planet, quietly governing the motion of charged matter for a great distance out into space. Saturn's magnetic field does all of these things too. It steers charged particles. It generates auroras at Saturn's poles, soft, glowing rings of light crowning the planet. It carves out a great protective bubble around Saturn, holding back the wind of charged particles streaming from the distant sun. And, as we have already seen, it is the magnetic field that takes hold of charged ring particles and rains them down into the planet. The field is not an abstraction. It is a working part of the Saturn system, doing real work, shaping the planet's environment in ways that can be measured. And it is precisely because the field can be measured so carefully that its strangeness was discovered. When a spacecraft flies through and around a planet's magnetic field, it can map that field in detail, charting its strength and its direction at point after point, building up a precise picture of the whole invisible structure. This is how the tilt of a magnetic field is found. By mapping the field thoroughly enough, one can locate the magnetic axis, the line along which the field is most symmetric, and compare it to the rotation axis, the line about which the planet spins. The angle between those two lines is the tilt. For the Earth, that careful mapping gives about 11 degrees. For Jupiter, about 10. For Saturn, the same careful mapping, carried out by the long orbital survey, with all the precision 13 years could bring, gives a figure smaller than 1/10 of 1 degree. To feel how small that is, it helps to translate it out of the language of degrees. 1/10 of a degree is a tiny angle. If you stood and faced straight ahead, and then turned by 1/10 of a degree, no one watching could possibly tell that you had moved at all. It is far below the threshold of anything the eye could notice. Saturn's magnetic axis and its spin axis are aligned to within that imperceptible sliver. For every practical purpose, the magnetic field of Saturn stands perfectly straight along the planet's spin. And that near-perfect straightness, set against the 11 degrees of the Earth and the 10 of Jupiter, is the whole of the anomaly. Saturn is doing something the other planets do not. Why does turbulence in the interior normally produce a tilt? It is worth making this concrete. The dynamo region of a planet is a place of rising plumes and sinking currents and swirling eddies, all of it shaped by the planet's rotation, but none of it perfectly orderly. The magnetic field is woven out of all that motion, and the motion is lopsided, stronger here, weaker there, swirling one way in one place and another way elsewhere. A field woven from lopsided motion comes out lopsided. Its strongest point does not sit exactly on the spin axis, because nothing in the turbulent interior is exactly centered on the spin axis. The tilt is the natural inheritance of the chaos. It is the chaos made visible in the geometry of the field. Every magnetic planet wears its interior turbulence on the outside in the form of a tilted, slightly off-center field. Every planet except Saturn, which appears to wear nothing of its turbulence at all. This is why the smoothing layer idea, the leading explanation, is so appealing, and it is worth turning it over once more, slowly. The idea asks us to imagine that the turbulent dynamo is still there, deep inside Saturn, doing exactly what every dynamo does, generating a lopsided, tilted, untidy field. But above that dynamo, the idea proposes, there is a special layer. A shell of fluid that is stably stratified, meaning it does not churn and overturn the way the dynamo region does. It rotates, smoothly and evenly, as a calm, steady shell. And the messy field generated below has to climb up through this calm shell to reach the outside. As the field rises through the calmly rotating shell, the steady rotation acts on it. Anything that is not aligned with the spin axis gets, in effect, averaged around the axis by the rotation, smeared evenly in a circle. The parts of the field that lean away from the axis are blurred and reduced. The parts that align with the axis pass through unaffected. The calm shell, in other words, works like a filter that passes the symmetric part of the field and suppresses the rest. By the time the field emerges at the top of the planet, it has been combed almost perfectly straight. The tilt has been smoothed away in passage. We, measuring the field from outside, see only the combed, symmetric result, and never the lopsided field that was actually generated far below. It is a genuinely elegant explanation, and it has real strengths. It does not violate the long-standing reasoning that says a dynamo needs asymmetry to function, because in this picture, the dynamo still has all the asymmetry it needs, down in the turbulent depths. The asymmetry is simply hidden, not absent. The explanation also fits with other things we suspect about Saturn's interior. There are independent reasons, having to do with helium separating from hydrogen, to think that Saturn may indeed have a stably stratified layer of just the right kind, in roughly the right place. So the smoothing layer is not an arbitrary invention. It is a mechanism that fits several pieces of evidence at once. But it has not been confirmed, and the honest position is to hold it as a strong candidate rather than a settled fact. No instrument has ever directly sensed that calm shell. Its depth, its thickness, its exact behavior, all of this is inferred and modeled rather than observed. The interior of a gas giant is permanently beyond direct reach. We cannot send anything down into it and have anything survive to report back. We can only measure the field from outside, study the planet's gentle interior oscillations through the faint quivering of the rings, and build careful models of what arrangement of layers would produce everything we see. The smoothing layer is the best current answer to the puzzle of the too perfect field. It is a good answer. It is not yet a proven one. And so the third mystery stands, quietly, as the subtlest of the three. The rings can be photographed. The hexagon can be photographed. The magnetic field cannot. It is known only as a set of numbers, a precise and invisible map, and the strangeness of it is a strangeness of numbers, the strangeness of a tilt that should be 10 or 11 degrees and is instead less than a tenth of one. But that quiet, numerical strangeness points to something almost poetic about the planet. Saturn must be turbulent within. The physics permits nothing else. No dynamo runs without chaos. And yet Saturn allows none of that chaos to show. It combs its field straight, hides its disorder behind a calm shell, and presents to the universe a face of flawless, untroubled symmetry. It is the most composed of the planets, outwardly. And its composure is the mystery, precisely because we know it cannot be composed inside. Part 5. Inside the planet and the family of moons. We have followed Saturn's three deep puzzles: the vanishing rings, the geometric storm, and the too perfect field. But those puzzles do not exhaust the planet. Saturn is a whole world, and a whole small system of worlds, and there is a great deal more to it that is not mysterious at all, only quietly remarkable. This part of the journey moves more slowly. It is a settling, a gentle tour around the rest of Saturn, into its interior, through its winds, and out among the great family of moons that travels with it. Begin with a descent into the planet itself. Imagine traveling down into Saturn, slowly, from the cloud tops inward. There would never be a moment of arrival, never a surface, never solid ground. There would only be layers, each one deeper and stranger than the last. The outermost layers are the visible atmosphere. Hydrogen and helium gas banded into pale stripes of cream and gold, wrapped in a high haze that softens every detail. This is the part of Saturn we can photograph, the bland and beautiful exterior. Going deeper, the gas grows steadily denser and warmer, the pressure climbing with every kilometer of descent. Before long, the hydrogen no longer behaves like a gas at all. It behaves like a hot, dense liquid, a deep ocean of compressed hydrogen with no surface and no shore. Deeper still, the pressure becomes extraordinary, far beyond anything that exists on Earth. And under that crushing pressure, hydrogen does something it cannot do in any ordinary setting. It is squeezed into a state called metallic hydrogen. In this form, hydrogen conducts electricity, behaving like a liquid metal. This deep layer of metallic hydrogen, electrically conducting and in constant churning motion, is the region where Saturn's dynamo runs. It is here, far beneath everything we can see, that the planet's magnetic field is born. At the very center, most likely, there is a core. A dense concentration of rock and ice and heavier materials gathered at the heart of the planet. But even the core is not quite what one might expect. The long study of Saturn's rings revealed something subtle about the interior. The rings, it turns out, quiver very faintly in response to motions deep inside the planet. Saturn's interior gently sloshes and oscillates, and those oscillations leave their mark on the rings, like ripples spreading across a pond from a distant disturbance. By reading those faint ripples, by treating the rings almost as an instrument listening to the planet, astronomers have begun to sense the shape of the core. And it appears not to be a sharp, distinct ball. It appears to be a vast, diffuse, fuzzy region, a core that blends gradually into the layers above it, with no clean boundary anywhere. Even at its heart, Saturn fades from one thing into another, rather than drawing a hard line. Now consider the planet's heat, because Saturn's warmth is one of its quietly important features. Saturn radiates more energy out into space than it receives from the distant sun. Far out in the cold, where sunlight is thin and weak, the planet is nonetheless gently glowing with heat of its own. Saturn is, in effect, a warm world from the inside. Where does that warmth come from? Part of it is ancient. It is heat left over from the planet's formation, from the long ago gathering together of all that gas, slowly leaking away over billions of years, a primordial warmth still draining into space. But part of the heat appears to be generated even now, in the present, deep inside the planet. The mechanism is gentle and slow. Within Saturn's interior, helium does not stay perfectly mixed with the hydrogen. Droplets of helium form and, being heavier, sink slowly downward through the lighter hydrogen toward the center. As they fall, they release energy, in the same way that anything falling releases energy. This slow, steady rain of helium deep inside the planet helps to keep Saturn warm. This inner warmth matters because it is the engine of Saturn's weather. The storms of Saturn, the bands, the jet streams, the great polar vortices are not driven mainly by sunlight, the way much of Earth's weather is. They are driven from within, powered by the heat welling up out of the planet's depths. And this is widely thought to include the hexagon. The great geometric storm at the northern pole is sustained, most likely, by the steady upward flow of Saturn's internal heat, an inner fire far below feeding the strange shape far above. There is something restful in that image. A planet far from the sun, deep in the cold, keeping its own quiet warmth, and using it to turn a slow gear of wind at its pole. Saturn's atmosphere looks calm, and in motion it is anything but. The pale gold bands that give the planet such a serene appearance hide some of the fastest sustained winds of any world in the solar system. Broad jet streams race around Saturn's equator at speeds that far outstrip the strongest winds ever recorded on Earth. The serenity of the view is partly an illusion created by the high haze, a soft veil drawn over a planet that is, beneath it, striped and dynamic, and endlessly in motion. Saturn has great storms as well. Roughly once in each long Saturnian year, which is to say once in about 3 decades, an immense storm erupts somewhere in the planet's atmosphere. It begins as a bright disturbance and then grows, spreading along a band of the planet, sometimes widening until it wraps an entire circuit of the world before slowly fading away. These rare planet-circling storms are sometimes called Great White Spots, and they are among the largest weather events anywhere in the solar system. Lightning has been detected in Saturn's clouds as well, flickering in storms far larger and far more powerful than any thunderstorm Earth has ever produced. But the richest part of the rest of Saturn is not the planet at all. It is the moons. Saturn is not a single world. It is the center of a miniature system, and it travels through space surrounded by the largest known family of moons of any planet. Well over 100 moons have now been confirmed in orbit around Saturn. They range from worlds larger than the planet Mercury all the way down to tumbling fragments only a few kilometers across, small dark chips of ice and rock. 2 of these moons deserve a closer and longer look because each of them is, in its own way, one of the most remarkable places in the solar system. The first is Titan. Titan is Saturn's largest moon and the second largest moon anywhere in the solar system. It is bigger than the planet Mercury, and it is the only moon known to possess a thick, substantial atmosphere of its own. Titan is wrapped in a dense orange haze, an atmosphere so deep and so opaque that for a long time its surface could not be seen at all. The moon was a featureless orange ball, hiding whatever lay beneath. When that haze was finally pierced by radar and by a probe that descended through it, Titan turned out to be a genuinely Earth-like world, at least in its shape and its processes, if not in its substance. Titan has weather. It has clouds and wind and rain. But the rain on Titan is not water. In the deep cold of Titan, far colder than anything on Earth, water is frozen as hard as rock. The rain on Titan is liquid methane, falling from methane clouds through a thick nitrogen sky. And that methane rain collects. Titan has rivers, carving channels across its surface. It has lakes and it has seas, broad standing bodies of liquid methane and ethane, pooled in basins near the moon's poles. Titan is the only world in the solar system, other than the Earth itself, that is known to have stable liquid on its surface. It is a world with shorelines, with river deltas, with a slow cycle of evaporation and cloud and rainfall, all of it running not on water but on methane, in a cold so deep it is hard to imagine. And beneath the icy crust of Titan, there is thought to be something more. A deep, hidden ocean of liquid water, a buried sea wrapped inside the moon. This hidden ocean is part of why Titan is studied so intently, and why it is so often named in the same breath as the question of whether life might exist anywhere beyond the Earth. Titan has an atmosphere, a weather cycle, organic chemistry in abundance, and very possibly a buried ocean of liquid water. It is one of the most intriguing worlds we know. The second moon to dwell on is Enceladus, and Enceladus is the opposite of Titan in nearly every way except its interest. Where Titan is large, Enceladus is small, only about 500 kilometers across, a bright, icy ball that could nestle comfortably within the borders of a single country on Earth. And yet this small moon is one of the most extraordinary objects in Saturn's whole system. Near the southern pole of Enceladus, there are great cracks in the ice, and from those cracks, Enceladus sprays. Continuously, out into space, the moon throws up enormous plumes of water vapor and fine ice grains, vast jets of frozen spray rising far above its surface. A small moon, fountaining water into the dark. The source of those plumes is a global ocean of liquid water hidden beneath the icy shell of Enceladus, wrapping the entire moon beneath its frozen crust. That ocean is kept liquid not by sunlight, which is far too weak out at Saturn, but by the flexing heat of Saturn's tides. As Enceladus orbits, the gravity of Saturn squeezes and stretches it, and that constant flexing warms the moon's interior, enough to hold an ocean liquid beneath the ice. The spray from Enceladus does something rather wonderful. It escapes the moon's weak gravity entirely, and it drifts out into space around Saturn, where it feeds one of the planet's faint outer rings. A small moon is quietly resupplying a ring of its giant parent, fountaining ice into orbit, keeping one of Saturn's rings stocked with fresh material. And the plumes carry, within them, traces of the chemistry of that hidden ocean. The spray of Enceladus is, in effect, a sample of an alien sea, lifted up off the moon and offered out into space, where a passing spacecraft was able to fly through it and taste it. That is why so small a moon is studied so closely. It hands its hidden ocean directly to anyone willing to come and catch the spray. Beyond Titan and Enceladus, the rest of Saturn's moons form a quiet gallery of oddities, and the gentlest way to meet them is simply as a slow procession. One large moon carries an impact crater so vast, so wide in proportion to the moon itself, that the whole body has the look of a familiar object, a great eye staring out of the dark. Another moon is sharply two-toned, brilliant white across one hemisphere and dark as soot across the other, as though it had been dipped halfway into shadow. And that same moon carries a strange narrow ridge of mountains running almost exactly along its equator, a seam encircling the little world. There are small moons that orbit within the rings themselves, the shepherds herding the ice. There are two moons that share a single orbit, forever swapping places in a slow, gentle gravitational exchange, drawing near and then trading paths, destined never to collide. Each of these little worlds is a calm place to rest, a quiet stop on a long journey before the path moves on to the next. This is the rest of Saturn, a planet with no floor, layered from pale gas down through an ocean of hydrogen to a deep metallic sea and a soft, fuzzy core. A world that keeps its own warmth, glowing gently from the inside, far from the sun. A serene face hiding ferocious winds and rare planet-circling storms. And a whole traveling family of moons, more than 100 of them, among which are a hazy orange world with seas of methane and a buried ocean, and a small, bright moon that fountains the water of a hidden sea out into the rings of its parent planet. Saturn is not a single mystery. It is a whole small system of quiet wonders, turning together in the cold and the dark. The descent into Saturn is worth making once more, slowly, because each layer of the planet has its own quiet character, and the journey downward is a restful one to imagine. It begins in the high haze, the soft pale veil of the upper atmosphere, cold and thin and lit by a distant sun. Below the haze are the cloud decks, layers of cloud at different depths made of different materials, the highest and coldest of one kind, the deeper and warmer ones of another. The pale gold color of Saturn comes from this stack of clouds, seen through the overlying haze. A softened, muted palette, gentle on the eye. Below the clouds, the atmosphere simply deepens. The gas grows denser and warmer, and the light fails, and a traveler would descend into a deep, dim, thickening ocean of hydrogen. There would be no drama to it, no sudden change, only a long, quiet darkening, the pressure mounting steadily, the hydrogen slowly ceasing to behave like a gas and beginning to behave like a fluid. Deeper still, The fluid hydrogen would become the strange metallic hydrogen, the electrically conducting layer. And here, far below all light, the planet's dynamo turns in the dark, generating the magnetic field. And at the very center would be the soft, diffuse, fuzzy core, a vast region of heavier material blended gradually into the hydrogen around it, with no hard boundary anywhere. The whole descent, from haze to core, is a journey through deepening. A planet that is all interior, all gradient, all the way down. The discovery of the fuzzy core is itself a quietly beautiful piece of science, and it is worth telling slowly. Saturn's interior, deep down, gently oscillates. It sloshes very slightly, in slow, deep rhythms, the way any large body of fluid will. Those oscillations are far too deep to see directly, but they have an effect at the surface and beyond it. The slow internal sloshing of Saturn tugs, very faintly, on the rings, and the rings respond. In certain places, the ring particles take up faint waves, gentle spiral ripples, driven not by any moon, but by the deep heartbeat of the planet itself. By studying those particular waves in the rings, astronomers found themselves able to listen, in effect, to the interior of Saturn. The rings became an instrument, a vast, delicate detector wrapped around the planet, registering the deep oscillations of the world within. And what that listening revealed was the soft, blended, gradual nature of the core. The rings, it turned out, had been quietly recording the heartbeat of Saturn all along, and we simply had to learn how to read them. Saturn's warmth, the heat it makes for itself, also rewards a slower look. The planet gives off, into space, roughly twice as much energy as it receives from the Sun. That is a remarkable statement. It means Saturn is not merely reflecting sunlight and re-radiating it. It is generating energy of its own, deep inside, and shining with it. Some of that energy is ancient, the leftover heat of formation, the warmth of all that gas falling together long ago, still slowly leaking outward after billions of years. And some of it is being made now by the slow separation and sinking of helium through the hydrogen, a quiet internal rain of helium droplets, each one releasing a little energy as it falls toward the center. Between the ancient heat and the helium rain, Saturn keeps itself warm, and that warmth, rising steadily from below, is the true engine of the planet's weather. The winds, the bands, the great storms, the deep hexagon, all of it is ultimately powered by the heat of the planet itself, welling up out of the dark interior toward the cold cloud tops. The moons of Saturn deserve a longer, gentler wander as well, because they are many and varied, and each is a small world worth a moment's quiet attention. We have spoken of Titan and Enceladus, the two most remarkable. But the family is far larger, and the smaller moons have their own quiet charm. Return first to Titan, because there is more to say. Titan is so large, and its atmosphere so substantial, that in many ways it behaves less like a moon and more like a planet that happens to orbit another planet. Its thick nitrogen atmosphere is actually denser at the surface than the Earth's own air. Its orange haze is made of complex organic chemistry, molecules built of carbon formed high in the atmosphere by sunlight, working on methane, drifting slowly down. Titan's surface, beneath the haze, has dunes of dark organic sand and broad plains, and the methane rivers and lakes and seas near its poles. The seasons of Titan, slow as Saturn's own, shift the weather from one pole to the other, and the methane evaporates and gathers into clouds and rains down again, a full weather cycle running on methane in a deep and patient cold. A probe that descended through Titan's haze long ago found beneath it a landscape startling in its familiarity. river channels and shorelines, and a soft surface. All of it shaped by flowing liquid, none of it shaped by water. Titan is the closest thing to an Earth-like world that the solar system has to offer beyond the Earth, and it is, at the same time, profoundly alien. Enceladus rewards a second look too. It is hard to overstate how surprising it was to find a small, icy moon far out in the cold, actively spraying water into space. Small moons are supposed to be dead worlds, frozen through, geologically silent. Enceladus is not silent. Its southern cracks, sometimes called the tiger stripes, are warm, and from them the plumes rise continuously. The global ocean beneath its ice is, by every indication, a real ocean of liquid salt water in contact with a rocky seafloor, kept warm by the tidal flexing of Saturn's gravity. When a spacecraft flew through the plumes and sampled them, it found water and salts and organic molecules and signs of chemistry of the kind that, on Earth, can support life in the dark, around deep-sea vents. None of this is evidence that anything lives in the ocean of Enceladus. But it is evidence that the ocean of Enceladus is the kind of place where the question is worth asking, and that a moon small enough to fit inside a single country may be one of the most important destinations in the solar system. And then the smaller moons, the quiet procession. There is the moon with the enormous crater, an impact scar so wide that the moon barely survived the blow that made it, and which gives the little world the look of a great staring eye. There is the two-toned moon, white on one face and dark on the other, with its strange equatorial ridge, a seam of mountains wrapping the moon almost exactly around its middle, the origin of which is still debated. There is the small, spongy-looking moon, oddly textured, very low in density, almost a loose pile of ice. There are the shepherd moons threading the rings. There are the two moons that share an orbit and trade places without ever colliding, performing their slow exchange over and over down the ages. There are tiny moons embedded in the rings that raise little wakes in the ice as they pass. The system of Saturn is not a planet and a few moons. It is a planet and a crowd, a busy, intricate, gravitationally interlocked family of more than 100 worlds, large and small, each one turning on its own path, all of them held together by the quiet, steady pull of the giant at the center. To picture Saturn fully, then, one has to picture all of it at once. The pale layered planet with no floor, the deep metallic sea and the soft fuzzy core, the self-made warmth rising through the dark, the fast hidden winds and the rare planet-circling storms, the draining rings, the deep hexagon, the too-perfect field. And around all of it, the great traveling family of moons, the methane world and the fountaining ice moon, and the long, quiet procession of smaller worlds beyond them. Saturn is not one thing. It is a whole small cosmos of its own, turning together, far out in the cold, patient and strange and beautiful. Part 6. The Long Survey, and how we came to know these things. It is worth slowing down here, in the gentle middle of the night, to consider not Saturn itself, but the long, patient effort by which any of this came to be known. Because none of what we have explored was obvious. None of it could be seen from Earth with the unaided eye. For most of human history, Saturn was a slow yellow point of light, and nothing more. Everything strange and specific about it, the ring rain, the deep hexagon, the too-perfect field, the fountaining of Enceladus, the methane seas of Titan, had to be patiently uncovered, across centuries, by people who kept looking. The first chapter of that effort was the telescope. When the telescope was first turned toward Saturn, the planet became a small disk with something puzzling around it. The early observers could not resolve what they were seeing, The shape seemed to change from year to year, sometimes appearing as handles on either side of the planet, sometimes appearing to vanish entirely. We now understand that they were watching the rings tilt as Saturn moved through its long seasons, opening toward the Earth and then turning edge-on until they nearly disappeared. But it took a long time and better instruments before anyone understood that Saturn wore a ring at all, and longer still, before anyone grasped that the ring was not solid. For centuries after that, Saturn could only be studied from a distance, from the surface of the Earth, through the blur and shimmer of our own atmosphere. Astronomers learned a great deal even so. They measured the planet's size and its slow orbit. They charted the largest moons. They saw the broad divisions in the rings. But the fine detail, the things that make Saturn genuinely strange, lay beyond the reach of any telescope on the ground. The real change came with spacecraft. The first to reach Saturn were passing visitors. 2 robotic craft, launched within a short span of each other, flew by the planet on their way to the outer solar system. They did not stop. They could not. They were moving far too fast, on trajectories carrying them onward into the dark. But as they passed, they turned their instruments on Saturn and gathered what they could in the brief window of the encounter. It was these passing craft that first saw the hexagon, and first revealed the rings in real detail, and first showed that Saturn was a world full of structure and puzzle. And then they were gone, carried on outward, leaving the questions behind them. To answer those questions, a different kind of mission was needed. Not a craft passing through, but a craft that would stay. And so a single spacecraft was sent to Saturn to do exactly that, to slow down as it arrived, to let the planet's gravity capture it, and to settle into orbit. It remained there for 13 years. 13 years is a long time to watch one planet. It is long enough to see Saturn change. The orbiter arrived during one season and departed during another, and across that span it watched the slow turning of the planet's year. It saw the northern pole emerge from darkness into light. It watched the hexagon shift its color from blue toward gold. It tracked the great storms that erupt once a Saturnian year. It flew, again and again, close past the moons, mapping Titan through its haze, discovering the plumes of Enceladus, and on one occasion flying directly through that icy spray to sample the water of a hidden ocean. It studied the rings from every angle, close enough to see the waves and the small vertical structures rippling through the ice. And it measured, with great precision, the magnetic field and found it impossibly aligned. Near the end of its mission, when its fuel was running low, the orbiter was given a final and daring set of orbits. It was sent to dive, repeatedly, through the narrow gap between the planet and the innermost edge of the rings, a slender, unvisited space that nothing had ever crossed before. From inside that gap, closer to Saturn than any craft had ever been, it gathered its final and most detailed measurements, including the readings of the planet's interior that revealed the soft, diffuse, fuzzy core. And then, when there was no fuel left to steer by, the spacecraft was deliberately sent down. It was guided into Saturn's atmosphere, to descend into the planet and be gathered into it, transmitting data for as long as it could on the way down. The craft that had studied Saturn for 13 years ended as a part of Saturn. There is a quiet dignity in that ending, a small machine becoming, at the last, a part of the world it had spent so long coming to know. It is worth dwelling on what this means for how we should hold the mysteries of Saturn. The hexagon, the ring rain, the two-perfect field, these are not ancient legends or vague impressions. They are careful measurements made by instruments, checked and rechecked across decades, by passing craft and then by a patient orbiter, and studied since by many minds working with the data those craft sent home. The mysteries are real because the observations are real. And the gaps in our understanding are honest gaps. They are the places where the careful work has reached, so far, the edge of what it can explain. There is something steadying in that thought. The unknown things about Saturn are not unknown because anyone has been careless or because the universe is playing a trick. They are unknown because Saturn is genuinely difficult and genuinely far away, and the work of understanding it is slow. We have learned an enormous amount. A slow, yellow point of light has become a world with a measured interior, a mapped family of moons, a charted magnetic field, and 3 specific, well-defined puzzles. That is not a failure of knowledge. It is knowledge doing exactly what it does, advancing patiently and being honest about where it has not yet arrived. And the survey is not over. There are ideas, even now, for returning to Saturn. There is particular interest in going back to Titan, to drift through that thick orange sky and study the methane seas more closely, and interest in returning to Enceladus, to fly again through the plumes and read more deeply the chemistry of that hidden ocean. Saturn will be visited again. The slow work of understanding it will continue, carried forward by people not yet born, using instruments not yet built. The questions we have followed tonight are not closed. They are simply the questions as they stand right now, at this moment, in the long, unhurried process of coming to know a distant world. There is a particular kind of patience built into all of this work, and it is worth admiring quietly. The people who first turned telescopes towards Saturn never saw the hexagon, and never knew the rings were draining, and never measured the field. They simply added what they could and passed the work on. The people who built the early passing craft knew they would get only a brief encounter, a few hours of close observation after years of travel, and they accepted that and gathered what those few hours allowed. The people who built the long orbiter knew that 13 years of patient watching would still not see a single, full Saturnian year. Each generation has handed the questions forward, a little better defined than they received them, and trusted the next generation to carry them further. The mysteries of Saturn are, in that sense, a shared and unhurried project, stretching across centuries, and the part of it we have followed tonight is simply where the project has reached so far. Part 7. Why the word was never the right one. We have traveled a long way around Saturn now. We have watched its rings drain quietly into the planet, grain by grain, a structure wider than the gap to the moon and thinner than a sheet of paper, slowly being absorbed by the world it adorns. We have stood at the northern pole and considered the hexagon, a geometric storm wider than 2 Earths, a deep tower of wind that has held its 6-sided shape for longer than we have had the means to watch it, present at one pole and absent at the other, for no reason we can name. We have followed the planet's magnetic field down into a turbulent interior and found the strange fact that what emerges at the surface is too orderly, too perfectly aligned, a calm face laid over a chaos that physics insists must be there. And we have wandered out among the moons, past the methane seas of Titan and the fountaining ice of Enceladus, more than 100 small worlds traveling with the planet through the dark. The title of this video called Saturn the Scariest Giant in the Solar System. It is worth, now, near the end, taking that idea gently in hand and turning it over, and then setting it down. Saturn is not dangerous. It threatens nothing and no one. It is impossibly far away, a world that takes light well over an hour to reach from the sun, a slow, pale giant moving through the cold of the outer system, entirely indifferent to the Earth and untroubled by it. Nothing about Saturn poses any harm to anyone. The rings will go on quietly draining, whether anyone watches or not. The hexagon will go on turning. The magnetic field will go on holding its impossible alignment. None of it reaches toward us. None of it ever could. So what did the word point at, if not danger? It pointed, really, at something else, something better. Saturn is unsettling in the way a very good magic trick is unsettling. Not because it threatens you, but because it does something in front of you that you cannot fully explain, and it does that thing on a scale so vast that the entire Earth would be lost inside it. A planet that eats its own rings. A perfect six-sided storm twice the width of our world, holding its shape across the decades. A magnetic field so orderly that our best theories struggle to allow it to exist. These are not threats. They are open questions. They are the places where a giant world, close to home, in our own solar system, is quietly doing something that the textbooks have not yet finished accounting for. And there is a particular feeling that comes from sitting with that. It is not fear. Fear is sharp, and it wants you awake, and it has no place in a night like this one. The feeling Saturn actually leaves behind, when you have looked at it long and closely, is something much quieter. It is the calm that comes from realizing how much is still unknown, even here, even close to home, even on a world that human beings have been watching through telescopes for 400 years. We have not run out of mysteries. We do not have to travel to the far edge of the universe to find them. One of the great unanswered questions in planetary science is simply the shape of a storm at the pole of the sixth planet, a planet you could see for yourself tonight as a yellow point of light if you stepped outside and looked. That is a comforting thought in the end, rather than a frightening one. It means the universe has kept some of its secrets close. It means there is still wonder in the familiar, still strangeness in the things we think we know. The ringed planet that every child draws, the planet on every poster and in every picture book, turns out to be genuinely, deeply strange, and we are only beginning, even now, to understand it. The mystery was always real. The fear was never necessary. And so we leave Saturn where it has always been, turning slowly in the cold and the dark, far out past the warmth of the sun, wearing its rings for a little while longer in this brief, bright chapter of its long life. Holding its strange six-sided storm at the northern pole, blue once and gold now, and turning, always turning. Showing the universe a face of perfect, untroubled calm, and keeping its chaos, as it always has, entirely to itself. None of it was ever something to fear. It was only the universe, close to home, still quietly keeping a few of its secrets, the way it always has, and the way perhaps we should be glad that it does. Let your breathing slow now. Let the day drift away from you, all of it, the whole long weight of it, gently loosening and falling away. There is nothing left to do tonight, and nowhere you need to be. Saturn will go on turning without you, patient and far away, wearing its rings, holding its quiet mysteries in the dark. Let your thoughts grow slow and soft and far apart. Let the stillness settle over you like something warm. Sleep well and good night.